Hello, guys and girls. Welcome all of you to Global Coding Cohort. This is Lekshman here. And today we are going to solve. You have already seen that from the thumbnail of this slide. The problem. I write it. And all the numbers between 0 to sum is equal to x. And this x is the input. Okay. Digits. Or sorry, not in ascending order. X is 0. So now write our sample ID. When our input is 9. First, we will solve it. Okay. Generally, using a normal logic, we will solve it. So that I will explain. Uh, One more condition is written there isn't. This should be in ascending order. You have to print a number whose sum is equal to x and its digits are is equal to x and digits in ascending order. So that means, for example, for 9, 1 plus 8 is 9, isn't? That means 18. Sum of this number. So this is in ascending order. Whereas 81, sum is also 9, but this is in descending order. We should not print this. We should print only this. Got it? You see the count, that means looping count. Okay. Okay. This is not part of our logic. This is just for our reference. This is part of logic. It is given 0 to 99 fixed, isn't, which is not going to change. Only the x integer is going to change. So okay, in normal way, first we will proceed. 0 to 99 means it's 100. Okay. If we give 100, it will loop till 99. That's why I can make condition over there. This place, uh, here we are going to get some numbers. Isn't? So we want the sum of numbers, sum of digits. Put There are a lot of ways. One is to convert that input number into string, then take it one by one. And again, if I convert it to integer, submit and return. That is one way. There is other way also. That is to loop while in greater than 0, sum equal to 0. Initializing sum 0 while I will explain this logic. Okay. So let me write it first. What I'm trying to do is so that is just assume that I'm okay. Let's take the same 18. What is 18 divided by? It is 1.8. What is 18 mod 10 is 8. Is 18 double divide 10, that is 1. Okay, in this case of 18, it is like this. Let's take 180 just for example, isn't it? 180 because some of you might misunderstand it. That's why I'm taking a huge number. So that means first digit, then remaining digit. Got it? We can obtain the first, that means the last one digit using mod operation. Then after when we do double division, then we can obtain the remaining numbers. We can use this number for the next loop. So that in the next loop, 18 will come over here and 8 will be extracted. Okay, in that way, it will be executed. So put mod 10 sum equal to sum plus equal to task and input equal to. I'm updating. Okay, after extracting one number, I'm updating the new number. If you want to understand this code deeply, then we can access this from a GitHub repository. You can use print in between, and you can see how this is getting executed and understand it very well. Okay, double division. And this okay. At this point, 18 8 first way 18 is how loop works for 3-digit number. Okay, and the next print 18 will come out here. Last one, one will come out because that's the only thing that's remaining, isn't it? So we said 180, 180 became 0 was extracted, then it became 18. The next step 8 is extracted, then it became 1. The last step 1 is also extracted, finally it became 0. That's why we have given like this. It has to run this loop. We are giving this condition for this loop to run until it becomes 0. There are other ways also. I'm just explaining this particular way of finding sum of digits. Okay, so now let's test it. Sum of digits. Okay, let's give 180, 9, 18, it's 9. then 81, 8, 10, 9, 55, it's 15, touch, it's working, what, 5, 0, 0, 1, 1, so it's working fine for various input. So now we will call it here. What's our x? We're assuming it to be 9 for this. For the time being, we are taking it as its input. Sum of digits I equal to x. If numbers are in ascending order, we have to check this out. Check ascending. It will return true if it is ascending, else it will return false. Okay, that is how it is going to work. Going to use variable called equal to true while ascending greater than 0, 3 equal to minus. We know that isn't. Obviously, it is going to be between 0 to 99. So I'm assuming it to be minus 1 here. Last equal to some sorry. Here we have to check this. If 3 equal to sorry 3 is last greater than 3. Last means last digit. Okay. If it is correct, then it is true. Else equal to false. First is the last one. Factor pathological one, which is to capture the remaining number. Okay. Else false and break the loop. Okay. Break the loop. Return what is present ascending variable. Let's check if it's working. Check with 81. Sorry, let's try with 8. It's fine. Correct. 81. 81, it's returning true. Oh, sorry. I have to check something. It's okay. Last, uh, we are going in reverse, isn't it? So we have to reverse our logic also. In that case, last should be so let's reverse the logic. Now let's see. So 81 is false. What about 18? So 18 to its first time is false. 18 was, let's check how it is coming around to. From the last, sorry. I didn't assign that what is prevision. After every step, we have to assign what is pre. I didn't update that variable. Let's check it now. But maybe then I should have added it there. 18 it should be false. Whereas we get it as false. Still we get that last response three. Oh no. This is minus one, isn't it? From here itself we have to reverse our logic. We are dealing only between 0 to 99. I'm going to give 100. Okay. So 80, it's correct. Except for 81, it is false. Okay. But now, okay, fine. So, now it's false. So it's not okay. I hope you have understood how I am debugging any errors. That means logical errors. Syntax error, we will get an error. Logical error, we have to find it and debug it. Okay. I hope you would have understood how I am debugging it. And let's see of the number friend friend number keeps going keeps going on. We have to count our loop is in right? We are using this counter, not part of logic. Let's check our loop count. All the correct? 9, 18, 27, 36, 5. Let's check our loop count. 100. Uh, let's give a number which is uh, greater than 9. What's the maximum number that we can get there? Plus 9, that is 18. Let's give that 18 and check. Not have any such output. Check for 17. We have 8, 8, 9. The loop that we took was 100. So all of two digit numbers, isn't it? So can we try this with any other logic? And that's what I'm now doing. Okay. I'm trying to reduce this to in count. We know that the second number should be greater than that, isn't it? Let's try it. That's some 190. Let's just simply check how this is. Put count equal to 0. That's too much. Yes, we have. Sorry, I made a mistake. So 10 will be 100. All numbers are between 0 to 9, isn't it? It may be 1000 or 999 or 9999, whatever. It is all the digits are between 0 to 9, isn't it? Because we have two digit number, find this way 45. Let's print and see whatever the things it date. Let's check this for a small number, okay? First, so that it's easy for us to validate. So 0, 1. Yes, that all numbers are greater. Let's check for 5. Yes. This way, less number of loop itself, I think our result can be okay. It's going to replace that with again. For based on our solution, then number equal to 2 to 10. We just have two digit number, isn't it? Plus. So that's why I'm doing something like this to make that as a number. It will look something like this, okay? 0 and 1, if there is 0 and 1 means 0 into 10 plus 1 means this is anyhow 0, 0 plus 1 going to be okay. And same is the case with let's take 34. 3 into 10 plus 4 30 plus 4, 34. This is how it's going to work out. Copy that. I have to replace all. Art of logic. Let's check how this is working. Loop count. We'll print the loop count. And for 15, they are working. Okay, I will comment this 15 because it's getting executed. When you just execute only this particular cell, then you have to uncomment this line. 18. Both behaves in the same way. That means if they are printing correctly, but see the number of count loop they went. It took 100. It took just 45. Which solution is then good? Obviously, our second solution is that let's check with 17. They both are printing same 89 and 89, but this took 100 groups. This took just 45. Let's check for 816. 978, 1678, 14, 13. Same output at different cost. Okay. 12, 11, 10, 45. If they are behaving in the same way, 8, 7, 6, 5, 4, 1, 0. For 0, this is printing and this is not printing. The reason is we are starting from I plus 1. Okay, that's why. Start from I, check how this is behaving for other output. Now it's printing looping 55 times for let's check for 9. So 55 loop itself, it was able to print all. Obviously, the below 0 also, no sum can be below 0 and no sum can be above 18, isn't it? Because 99 is our limit. So, but the best solution is this 15 55 loop. Like I think you would understand the importance. I check the highest input and you also with the lowest input. That's why I went from 18 to 0. So till 1, this both of this solution was working fine. But when at input 0, it printed 0 and it didn't print. Then we fixed. So like this, we have to test both the ends, then with student value, with all possibilities, then we check, we can fix our logic. So now both solutions works well, but second one is better than the first one because it is just taking 55 loops, taking 100 loops to find the same answer. Okay, looping less number of time, that is what is better, isn't? Whereas this is still looping 100 times. So this is our final solution. Going to delete this. Going to delete this. Okay. So that's it for today's session. I hope all of you understood well solution, and meet you with another problem. Until then, bye bye.